again to the continuation of the topic stoichiometry. Please don't forget to subscribe to our YouTube channel and also see the links to the previous videos in the description box below. Okay? Now, look at the question we have. They say, what volume of distilled water must be added to 50 cm cube of 0.25 molar sodium carbonate to make 0.05 molar solution? Now, from the question you see here, 0.25 is bigger than 0.05. That means this is more concentrated than this. When you add distilled water to this higher concentrated solution, you will get this lower concentrated solution. Now the question is, how much water are we to add to this 50 cm cube of this to get this? That brings to our notice that we use dilution formula. Dilution formula said that C1 V1 is equal to C2 V2. Now C1 will be the concentration we have. 0.25 times V1 is 50 equals to our C2 is the concentration we are looking for, 0.05 times V2. We are trying to get the final volume. Then we now say V2 equal to 0.25 times 50 all over 0.05. Okay? Then that will be giving us 250 cm cube. So it means that the final volume of this we are to get is 250. But that is not the quantity of water to add. Remember, this one is already 50 cm cube. And you have to add water to it to get to 250 cm cube. And when you add water to it to get to 250 cm cube, you will be getting this quantity. That is to say, look at it. Here is 50 cm cube. That is the high concentrated one. That is the one of 0.25. Now the question is, when you add water to it, you will be getting 250 cm cube. And when you get 250 cm cube, that will be giving us 0.05 molar. What quantity of water are we to add? You say 250 minus 50, that will be 200 cm cube. That is the additional water we have to put to get to this 250. Therefore, you say that quantity of water to be added will be equal to 250 minus 50 equal to 200 cm cube. So when you add this 200 cm cube of water into the 50 cm cube of the high concentrated one, you'll be getting 250 cm cube of the total, and which is equivalent to 0.05 molar. Now we go to the question number 2. In question number 2, we notice that they say 6 moles of nitrogen reacts with 14 moles of hydrogen to form ammonia. Find the limiting reactant. What is the excess reactant and the mass of excess reactant that remains unreacted, and what are the residual gases? Before you solve question on stoichiometry, you must have an equation, a well-balanced equation. And look at it. Nitrogen can only react with hydrogen when being in gaseous form to give us ammonia. So, if you want to balance it, you put 3 here and put 2 here. This is gas, gas, and gas. From here, for us to get the limiting reactant, we say consider the reactants. Consider only the reactant side. Here 1 mole, here 3 mole. 1 mole of nitrogen reacted with 3 moles of hydrogen. Okay? Now in the question, 6 moles of nitrogen is what they reacted with 14. Now I want to check. If 6 moles of nitrogen reacts, how many quantity of how many moles of hydrogen should you react with? You say 6 times this divided by this. 6 times 3 divided by 1. That will be 18 moles of hydrogen. You can see that from our well-balanced equation, it is meant to be that 6 moles of nitrogen must react with 18 moles of hydrogen. But what did they react? The manufacturer reacted 6 moles of nitrogen with 14 moles. Since he reacted with 14 moles, it means that the 14 moles of nitrogen he reacted with is not up to the required moles of hydrogen he is meant to use. So you say because of that, hydrogen in this reaction is limited. It's limited because he used 14 moles instead of 18 moles. Then you now say the other one, automatically the nitrogen will be the excess. Once one of the reactants is limited, the other one must be excess. That is the implication. Then once the other one is excess, the other one must be limited. Okay? So we have gotten our limiting reactant and our excess reactant. Our limiting reactant is hydrogen, our excess reactant is nitrogen. Now we go to the next question. What is the excess reactant? Excess reactant is nitrogen. Okay? And the mass of excess reactant that remains unreacted. Let's see how to get it. For us to get the mass of excess reactant that remains unreacted, we also use the well-balanced equation, which tells us that 1 mole of nitrogen reacted with 3 moles of hydrogen. Then, since hydrogen is limited, what quantity of hydrogen did he use here? He used 14 moles of hydrogen. That tells us that if we cross multiply, we will now get the actual amount of nitrogen he is supposed to use in the reaction. How do we get it? 14 times 1, 14. When we cross multiply, we say 14 times 1 all over 3. 14 times 1 all over 3 will be giving us 4.67 moles. So it means that it's 4.67 moles of nitrogen that is supposed to react with 14 moles of hydrogen. 4.67 moles of nitrogen is what the producer is supposed to react with 14 moles of hydrogen. It's supposed not to use these 6 moles. These 6 moles supposed not to be used. Instead, it's 4.6 moles. Okay? Now that tells us that amount of excess reactant is, what is the nitrogen that he used? He used 6 moles of nitrogen. He used 6 moles of nitrogen. Then, but he's supposed to use 4.67 moles. So the 6 moles that he used should subtract the 4.67 moles that he's supposed to use. So be giving us 1.33 moles of nitrogen gas. So this is the amount of the excess reactant, which is nitrogen, that is in excess. Okay? Then we now go to what are the residual gases. For us to get our residual gases will be the amount of that excess reactant plus the amount of the product we have. That will be our residual gases. Amount of that excess reactant plus the amount of the product we have. Now let's see how we get it. Let's see how we can get the amount of the. We have gotten the amount of excess reactant. That is 1.33. That is the amount of excess reactant that is in excess. So the amount of excess reactant that is in excess plus the amount of the products we have. Now let's see the product. For us to see the amount of product that we have, we must use only the limiting reactant. We must use only the limiting reactant. And what is the limiting reactant? That is hydrogen. We say 3 moles of hydrogen must produce 2 moles of ammonia. So, what amount of hydrogen did we use in the reaction? We use 14 moles of hydrogen. That will be giving us how many amount of ammonia? 14 times 2 all over 3. 14 times 2 all over 3 will be giving us 9.33 moles of ammonia. So this is the amount of ammonia or the moles of ammonia produced in that reaction. So the residual gases we will have is this excess reactant that is in excess, which is 1.33 moles of nitrogen plus 9.33 moles of ammonia. So this 1.33 moles of nitrogen, which is the amount of the nitrogen or the excess reactant that is in excess, plus 9.33 moles of ammonia, that is the residual gases. Please do not add this thing up, these two figures, don't add it up because they are two different gases. Just write it this way, okay? That is our answer. Thank you for watching the video. Please check the previous, the links to the previous videos we have in the description box below so that you see other videos we have.